so that they're relatively the same when they hit.
Okay.
So I'm a lazy guy. I don't do too much when it comes to extra coding. All right, so what I'm trying to show here is these next steps. Oh, look at this. All lines up just perfectly. So we're doing the debug code, and this red line that you see here represents the vector that the direction the player is facing. The player is currently facing, it looks like, about a minus 45-degree angle. And I don't know why it says minus 72, but oh, that's it. Right, so this is the current angle of the player, but then we coordinate this down into steps of 45. So this is going to come down to being closer to minus 45, and so we'll default to minus 45, which is this angle right here. So the first step is we calculate an angle. We calculate a vector based on the player's angle, and we get this line. And then we will, this is very hard to read, so we'll just go down here. So this line of code could essentially be considered to be this vector here that you're seeing. And as you can see, I fired, and my arrow is traveling along that line there. Now, why is it not on the line? This goes, it's kind of hard to see, but there's a shadow here, and then there's the arrow here. Really, the body for the arrow is right here on the line. The center of this graphic is right here. But because we're using an isometric graphic that has a shadow element, does this make sense? Are you seeing what I'm saying?
Yeah. So if we had a box around the graphic, then it would be on the line.
Yeah, if we had a box around the graphic, you'd see that the center was right here, but the rendered part for the arrow is up here, and the rendered part for the shadow is down here.
Right.
So that it looks right when it's flying, but the physical body is here, which gives you this large margin of space where you can actually hit the enemy. So what am I saying here? Okay, so we have this line, and it's just this long line, and then we scale it. Now, I couldn't give you a representation of that because a scaled vector here is going to be this little tiny, like 1 pixel length dot, because it's a math space thing. It's not a visual thing. I can't make it so you could see this arrow. But the point is that we start off with an angle. We calculate a line, which is a vector, based on that angle. And then we have already generated the proper graphic at this point. And then we simply scale that vector to be the length of our arrow speed. So if our arrow is moving at 150 pixels per second, it will take this long line and then scale it down to 1, and then scale it back up to 150 pixels long. Then we take those two components, the x and y components, and we put them into set linear velocity. So, this sounded so much better on paper when I was doing it, but it's still not clear. So,
yeah, I think there's a couple of things involved here. One is the concept itself, and then the other part is the math. I think for me personally, I would do well to understand the concept, and then can I come back to the math because
let me slow the players down to 1 player and make it slow so you can see me firing. Because what I did was I played lines showing you what's going on, so you can kind of see how this is firing and scaling and stuff. And hopefully I got it right. Coming 5, and let's make that 1, 1, and 1. Max enemies 1. Guy moves it. Let's make him move at 10 pixels a second. Make it a little bit faster. Restart the game, and then I'll fire, and you'll kind of see what's going on. So where's our enemy? Oh, let's put him on screen. Offset 150. And generate on the screen. I don't know why he's not deleting. Generate another one.
It's like a laser archer.
Yeah. Oh, we're gonna have laser turrets later. Patch, remember?
Oh yeah.
The zombie game is only as good as the laser turrets. I got 5 enemies now, so this will be a little more interesting.
Okay, so what are we looking at here?
So what we're looking at here is the yellow line is the aim line, and then the red line was supposed to be the adjusted velocity line, but I'm not doing it right. So it was supposed to get shorter than the red one. So it's supposed to be yellow and then turn red, and the red one would be the length of the actual velocity vector, but I did something wrong. It's not working.
Okay.
So, but when I commit this code, this will be working. What you'll see is yellow for a moment, and then it'll turn red, and it'll be shorter. And that will demonstrate the principle, which is a velocity vector has a certain length. And so the x and y components we pull out of that vector, which determine where it faces and how long it is, are used to actually set the velocity of the arrow. So it was just supposed to demonstrate the math. It was supposed to give you an ability to look at what happens on each step of the math. And I totally failed because something is not right with my math.
Okay. Well, maybe we should come back to that one next week and
I could at the very least demo it working correctly so people can see.
Yeah. And in the meantime,
the principle here is incredibly simple. The thing is I'm driving at is that people who want to make any kind of a shooter absolutely have to understand vector math. You have to. You can't get around vector math for aiming, creating velocity vectors, steering. All of these behaviors require vector math. But vectors are very simple. I give you a library. That's the Math2D library that you can get as a plugin. And you can take an angle, convert it into a vector, scale the vector to be the length you need it to be, and then apply it as the velocity or whatever it is, the force, whatever you're using it for in that circumstance.
Okay, so let me make sure. I want to restate that just so people are clear of what you just said, and that is that you can do all this stuff manually, but you've created a plugin which is in the Corona plugin store that they can add to their project, and then it helps them do the math so that they don't have to be vector math wizards in order to use this.
As you say, let me turn my camera on instead of the screen here. As you say, better to understand the principle than necessarily the mechanics of it. I think, sort of paraphrasing you there.
Something like that.
And my library lets you understand the principle without knowing the cosine, sine, arctangents, and all that nonsense that is, you know, this is one of those things where you can kind of know how to do it without knowing the background. So you didn't have to have that class yet in school. You can learn it for game development. And man, by the time you get to that in school, if you're a younger person and take in geometry and all that later, you're going to be ahead of your class at that point because you're going to be like, yeah, I already know how to do vector math.
You know, and that's a good thing because you know sometimes you just need to get something done, right? And then once you're confident that it's going to serve your purposes, or you're at a point where you're ready to learn the details, right? Then you can kind of dig into it. But sometimes you need a little bit of the training wheels kind of thing, right? I mean, there's a reason.
I kind of think so, yeah.
Yeah.
I see a lot of times in the forums, people ask questions, and they're trying to do vector math. They are literally trying to solve these things, and they constantly do like, well, I did a cosine and thing, and they show you their code, and you're looking at it going, man, you could just do that in one line of code, and then later on when you know how to use the tool, then you can go learn what all that stuff is. But it's, first of all, it's trigonometry, but the math that goes behind doing vector math is kind of deep math. If you haven't already had it, I mean, you have to understand all these principles about angles and the limitations of the sine, cosine, arctangent, and the concepts that go behind that. And you can't just walk in and go, okay, this is the one way it works, I'm going to do it. No. There's a lot of stuff you have to understand.
Yeah.
So better to use a tool to grasp the higher concept first, and then worry about the fundamentals when you get to that point in your schooling, or if you really need to dig into it for another reason.
And this is almost back to where we were at the beginning of the show, where we were talking about getting something out there, getting it working, and then optimizing it later, right? It's better to have something in place to see if it's even going to be a success before you spend all the time optimizing it and then release it.
Yeah. I mean, you know, I was in their shoes, and I did exactly what they're doing. I went through it, and I kind of learned it longhand. But man, at that point, I was wishing that somebody else would just give me a function that would just do it. Because I wanted to get it done, you know. I spent days trying to figure this stuff out. Oh, speaking of which, I'm going to give you a link for the show to my #1 document where people who are not going to listen to this advice and they're still going to go learn all this stuff. like Appendix B, and I'll tell you what it is for the show, but it's a book that I have on my bookshelf that is now free in PDF, and it's got this appendix in it that goes through the trigonometry, the sine, cosine talk, and whole concept of the vector. And I still refer to it to this day when I forget something, some fundamental detail. So it's a great reference that I think people who want to dig in, they can use. It's very short and understandable.
Awesome. Okay. Well, okay. So in the meantime, you send that to me. I'll put a link in the show notes. I think what to take away from today's code review, like you said in the beginning there, that people need to, one, go back and watch some of the previous videos to learn how that mouse functionality is being built up, and then also take that along with what is presented today. Then you can download the full source code. Links will be in the show note, and then you can step through it and see how everything's functioning. And like we always encourage here, tweak it, break it, right? You can always reload it. You can always go back and unzip the file again and just internalize what's going on there. And if you have questions, let us know. Post your comments in the video comments below, and let us know, and we will try to answer those on a future episode. All right? Okay. Well, next time we're going to do what? So that was firing. Do you want to do terrain or killing enemies next time, or do you have something new?
Well, killing enemies is a super simple step, so we'll do killing enemies, and then we'll go right into terrain. I mean, there's nothing to it, right? It's a collision handler, and you do something. The arrow hits the enemy, you do something. So what do? We'll go over that next time and talk about what the something is, and then we'll go right into terrain rendering.
Excellent. All right.
And then after we get done with terrain rendering, we can finally get into pickups and traps and stuff.
Oh, sweet.
We can start making this game actually strategic.
Right.
Now it's just us shooting, and that's so fun.
Up to this point, though, I think there's been plenty of stuff to cover and lots of groundwork, and so you definitely can't skip these pieces, right? I mean, there's no point in having traps and all that other business if you can't move the player around, you can't shoot enemies, all that stuff. So, so join us tomorrow night. We're going to have Corona Geek After Dark. This is going to be number 17. I think we're going to talk about the iPad Pro. I've got the Apple Pencil. We're going to talk about Google Play's requirement for you to mark your games as ad-supported if they are ad-supported, and a whole bunch of other things. So join us tomorrow night, and until then, we'll see you next Monday. Have a great week, and happy coding.
Auf Wiedersehen. Tschüss.